Hello everyone. Today we see an important concept of chemistry, that is the nature of light. Already the nature of light topic is broadly comes in physics also. But why we are discussing in the atomic structure means the structure of atom. The structure of atom generally based on quantum theory. There is mainly two major concepts are there which were used in the discovery of structure of atom, or quantum theory and spectra of atoms. It is known as atomic spectra. Means quantum generally the structure of atom is explained in terms of on the base of quantum theory and atomic spectra. So again, this quantum theory and atomic spectra are related exactly to the nature of light. So actually they explained the quantum theory or atomic spectra in these two processes, in these two theories, in these two concepts. The interaction of the light, the interaction of light takes place to the matter. The interaction of the light takes place to the matter. So with the help of that type of experiments only, they given quantum theory. Even in the receiving the spectra is also the interaction of the light to the matter takes place. That's why there is a perfect relation takes place in the discovery of structure of atom and the nature of light. Okay, that's why we are discussing about the nature of light. Okay, and starting times it was it was imagined that the light is having a very small invisible particles which were given by Newton. At first Newton Newton said that the light is consists of very tiny particles which are invisible, which are known as corpuscles. That is known as corpuscular theory. So what is mean by corpuscles means very tiny invisible particles, very small, simple, invisible particles. So corpuscular theory of that is known as corpuscular theory of light, in which the main point is actually it was given by Newton, in which it was given that the light is consist of very small, simple, invisible particles which are named as corpuscles. But there is a no perfect evidences are there at the time. At that time there was no perfect evidences are there to prove that the light is consist of very small particles. Okay, then afterwards many scientists applied wave theory, nothing but wave nature for many scientists applied and also accepted the wave nature for light. Okay, so it is other thing that after some years, after some decades, again it was proved, again it was comes to the matter that the light is consist of wave nature and also corpuscular nature. Okay, starting it was given corpuscular theory, but it loses its existence after the introducing of wave nature for the light. Actually, the properties of the light, many of the properties of the light are explained with the help of wave nature. That's why wave nature become a very dominant theory when compared to the corpuscular theory. Okay, so according to this, if you observe the wave nature, if you see X-rays, gamma rays, normal ordinary light, you know that VIBGYOR light, ordinary light contains a mixing of 7 colors, that is a VIBGYOR. 7 colors means there are 7 types of radiations. There are 7 types of radiations which are having some different wavelengths, different frequencies, some properties. They move in the form of waves. They move in the form of wave, and they also their movement is due to the oscillation. Their movement is due to the oscillation of electric field and magnetic field. The movement of light is due to the movement of light in the form of wave is due to the oscillation of electric field and magnetic field perpendicular to each other, and both are again perpendicular to the propagation of the light. Okay, for example, if you see this is the light propagation. Okay, this is the path of light. If it is taken as a path of light, so there is a formation of two fields are there: magnetic field, electric field. That's why this X-rays, gamma rays, all these visible rays, ultraviolet rays, cosmic rays, all this type of rays are simply not only known as rays, they are also known as radiations. Which type of radiations? The perfect name for them is electromagnetic radiations. Electromagnetic radiations. Why they are known as electromagnetic radiations? Means there is a electric field formation and magnetic field formation is there, which are perpendicular to the path of their propagation path. Okay, next one more important point here. So for example, so this is the field. So actually, like this, this is the propagation of light. The propagation of light ki la vertical ga. Okay, the vertical. So if you see what is the angle perpendicular. So the direction లో పోతుంది, ఇది exactly ఇట్లా ఉందంటే that is 90 degrees. అంటే path of the light కి దీనికి ఎలా ఉంది, మనకి exactly 90 degrees ఉంది. But what about this field? What is this field means? This is a electric field. Okay, this is electric field. Means vertically there is a formation of electric field takes place which is perpendicular to the path of light. So the vertically and perpendicularly to the path of the light ante, for example, ఒక రోప్, ఒక పర్ఫెక్ట్ తాడు తీసుకొని ఒక పిల్లర్ గట్టి మనం షేక్ చేద్దాం. సో షేక్ చేస్తే అది ఎట్లా షేక్ అవుతుంది? సో మనం ఇట్లా షేక్ చేస్తామంటే ఇట్లా వేవ్స్ ఫామ్ అవుతాయి. సో ఆ వేవ్స్ ఎట్లా ఉంటాయి, మన ఎర్త్కి కంపేర్ చేస్తే సో ఎర్త్ సర్ఫేస్కి అవి ఇట్లా వర్టికల్గా పోతాయి, సేమ్ డైరెక్షన్. సిమిలర్గా సో పాత్ ఆఫ్ లైట్కి సేమ్ ఈ ఫామ్ అయిన ఎలక్ట్రిక్ ఫీల్డ్ ఎట్లా ఉంటుందంటే ఎగ్జాక్ట్లీ పర్పెండిక్యులర్ అండ్ వర్టికల్లీ పర్పెండిక్యులర్ టు ఇట్. ఓకే, సో దిస్ ఈజ్ ద డైరెక్షన్ ఆఫ్ ఎలక్ట్రిక్ ఫీల్డ్. This is the direction of electric field. So next, whatever the magnetic field, as we said, there is also formation of magnetic field which is also perpendicular to the path of light, and perpendicular to the electric field. Means simply we can say it is horizontally and perpendicular to the path of light. For example, మూమెంట్ ఆఫ్ స్నేక్, మనకు స్నేక్ మూమెంట్ చూసి ఎట్లా ఉంటుంది, దట్ ఈస్ ఆల్సో జస్ట్ లైక్ వేవ్. కానీ ఎర్త్తో కంపేర్ చేస్తే ఎట్లా ఉంటుంది, ఎర్త్తో కంపేర్ చేసి దాని మూమెంట్ సో ప్యారలల్గా ఉంటుంది. ఓకే, అంటే ఎర్త్కి మనం ఇంతకుముందు రోప్ మూమెంట్, వేవ్ మూమెంట్కి మన ఎర్త్ డైరెక్షన్కి, ఎర్త్ ఉన్న ప్లేన్కి చూస్తే వర్టికల్గా ఉండే 90 degreesతో. సో ఇక్కడ ఎర్త్ సర్ఫేస్కి నెక్స్ట్ స్నేక్ మూమెంట్ ఎట్లా ఉంటుంది, ఎగ్జాక్ట్లీ ప్యారలల్. ఓకే, అంటే ఇప్పుడు ఆటోమేటిక్గా ఇప్పుడు స్నేక్ మూమెంట్ డైరెక్షన్కి రోప్ డైరెక్షన్ ఎట్లా ఉంటుంది, పర్పెండిక్యులర్ టు ఈచ్ అదర్ అండ్ బోత్ ఆర్ ఇన్ ద ఫార్మ్ ఆఫ్ వేవ్. ఓకే, మీన్స్ టు ద పాత్ ఆఫ్ లైట్, there is a horizontally and perpendicularly, so there is a formation of a field that is magnetic field. So try to draw the diagram perfectly. So this indicates H. So magnetic field, electric field, so directly E. This is the path of light. So like this. Okay. So how you define a wave? How we can define a wave means it is nothing but a disturbance. సో ఫర్ ఎగ్జాంపుల్ మనం వేవ్ పర్ఫెక్ట్గా అబ్జర్వ్ చేయాలంటే ఇప్పుడు ఫర్ ఎగ్జాంపుల్గా స్టడీగా ఉన్న వాటర్లో ఒక స్టోన్ వేసినాం అనుకోండి, జస్ట్ మిడిల్లో స్టోన్ వేస్తే ఆటోమేటిక్గా ఏమవుతుంది, వాటర్ సో ప్లెయిన్గా సైడ్కి వచ్చేస్తే ఇట్ ఈస్ నాట్ లైక్ దట్. సో హైట్స్ వస్తాయి, డౌన్స్ వస్తాయి, అప్ అండ్ డౌన్స్ వస్తాయి. సో అప్ అండ్ డౌన్ దట్ మూమెంట్ ఈజ్ కాల్డ్ వేవ్. మీన్స్ ఇట్ వాజ్ ఆల్సో సైంటిఫికల్లీ డిఫైన్ యాజ్ ఇట్ ఈస్ ఏ పీరియాడిక్ డిస్టర్బెన్స్. పీరియాడిక్ డిస్టర్బెన్స్ అంటే సో మనకి ఒక రెగ్యులర్ ఆర్డర్ ప్రకారం వెళ్తుంది. ఓకే, అంటే ఒకసారి ఇంక్రీజ్ డిక్రీజ్, ఒకసారి 2 టైమ్స్ ఇంక్రీజ్ 2 టైమ్ డిక్రీజ్ అట్లా ఉంటుంది మనకి. లేకపోతే 2 టైమ్స్ ఇంక్రీజ్ ర్యాండమ్గా ఉండదు, 1 టైమ్ ఇంక్రీజ్ డిక్రీజ్. మీన్స్ దెర్ ఇస్ ఏ పీరియాడిక్ డిస్టర్బెన్స్ టేక్స్ ప్లేస్ ఫ్రమ్ అండ్ ఆరిజినేట్ పాయింట్. అంటే ఒక ప్లేస్ నుంచి స్టార్ట్ అయ్యి సో ఎట్లా మూవ్ అవుతాయి అంటే అప్స్ అండ్ డౌన్ ఒక రెగ్యులర్ ఆర్డర్లో మూవ్ అవుతాయి. దట్ టైప్ ఆఫ్ మోషన్ ఈజ్ కాల్డ్ వేవ్. ఓకే, నెక్స్ట్ if you observe, so wave generally how you write the wave, so it is a wave. So single wave means okay, it is treated as a wave. Okay, so the wave is having a generally there is some particular properties are there for waves. Okay, what are the particular properties? So the main properties of wave are, so the wave means not only the waves of light, okay, normal light, x-rays, gamma rays, cosmic rays, ultraviolet rays. So all types of the rays which are known as electromagnetic radiations are having this type of waves only, and all are having same type of properties. So what are the main properties of wave to explain it? అంటే ఒక వేవ్ మనం ఎక్స్ప్లెయిన్ చేయాలంటే సో విచ్ ప్రాపర్టీస్ ఆర్ రిక్వైర్డ్? సో వన్ ఈజ్ the main property of is wavelength that is indicated by lambda. So what is wavelength? First I will explain. So if you see a wave, this is the highest part, this is the lowest part, means this is known as height, this is known as depth. Okay, so one highest point, one lowest point completes, that is known as a perfect wave. If the distance between the 2 points is calculated, that is known as wavelength. So the one more important, so what is the general definition for wave means, for example here we are taking 2 waves. Okay, so 2 waves తీసుకుందాం. సో ఇక్కడ so this is the highest points are known as crest, means this height one, upper one, down one. The upper parts are known as crest, the downwards are known as trough. Crests and trough. So this is the first crest, this is the second crest. Okay, so now this distance is generally the distance between the 2 continuous crests, or the distance between the 2 continuous, nothing but the 2 successive crests are the distance between the two successive or two continuous troughs is known as wavelength. Okay, so main important units of wavelength. So already we know that it is a very small length. So wave and just not a big one. So wavelength is generally very small units, very small length ఉంటుంది కాబట్టి సో జనరల్ స్మాల్ యూనిట్స్ ఏంటి మనకి the units which are used to measure them is angstroms, nanometers, picometers generally. Okay, so we know that 1 angstrom is equal 10 for minus 8 centimeters, nanometer equal 10 for minus 9 meters, so picometers equal 10 for minus 12 meters. Okay, like this very small units are used to measure the wavelength. Okay, next we see one more property, so that is a frequency. Frequency of light. Frequency light indicated with nu. The symbol is known as nu, nu. Okay, so what is the frequency? So frequency means mainly it indicates about the speed of the wave. Okay, for example, if you take a particular point, okay, for example we are discussing at this point. Okay, from this point how many waves are traveled, from this point in 1 unit time. Generally 1 unit time is taken as a 1 second. Okay, 1 unit time is kuntam, but generally it is taken as a in 1 second. Okay, at a simple oka particular point nunchi how many waves are passed away through a particular point in 1 second of time. So that is called a frequency. Okay, the number of waves passed through a given point in 1 second of time is known as frequency of that light. Okay, so per 1 second calculate chestam kabatti that is known as units of second inverse. So what is the common part? Second inverse is also known as hertz. Hz, that is known as hertz. So there is one other one is kilohertz. So hertz, kilohertz nearly same, but in terms of kgs, in terms of k, that is given kilohertz means 10 power 3 hertz. It is not a separate unit, but there is only two units, second inverse, hertz. Okay, there is no particular conversion is also there, because the numerical values of 1 second inverse is exactly equal to the 1 hertz. Okay, but kilohertz raste, so 10 power 3 hertz. So one more unit is also there, cycles per second. So cycles per second, why you are using the word cycles means so already we define the frequency is the number of waves అంటే సో దిస్ ఈజ్ ద కంప్లీట్ వేవ్. సో కంప్లీట్ వేవ్ అంటే ఇక్కడ స్టార్ట్ అయిపోయింది మళ్ళీ ఎండ్ అయిపోయింది. సో ఈ టోటల్ ఈ రౌండ్ అప్ ఏమంటామంటే దిస్ ఈజ్ కాల్డ్ ఏ సైకిల్. ఓకే, టోటల్ ఒక సైకిల్ అయిపోతే ఒక వేవ్. సో అట్లా నెంబర్ ఆఫ్ వేవ్స్ని మనం నెంబర్ ఆఫ్ సైకిల్స్ అనొచ్చు. ద నెంబర్ ఆఫ్ సైకిల్స్ ఇన్ 1 second it treated the frequency. Okay, next the one more property, is wave number. Wave number is treated as a symbol is a nu bar. Okay, so nu bar. So what is a wave number? So it is also the number of waves. But not in the moving stage. The number of waves present in a particular length. Okay, ఒక పాయింట్ నుంచి ఎన్ని మూవ్ అయ్యో క్యాలిక్యులేట్ చేయం మనం. సో ఒక పర్టికులర్ లెంత్లో, ఫర్ ఎగ్జాంపుల్ ఒక 1 సెంటీమీటర్, ఓకే 1 సెంటీమీటర్ అనుకుందాం జస్ట్ అప్రాక్సిమేట్లీ. ఈ 1 సెంటీమీటర్ లెంత్లో హౌ మెనీ వేవ్స్ ఆర్ ప్రెసెంట్. సో ఒక వేవ్ అంటే ఇక్కడ ఇది ఒక కంప్లీట్ సైకిల్ అవ్వాలి. 1 కంప్లీట్ సైకిల్ గివ్స్ టోటల్ 1 వేవ్. సో ద నెంబర్ ఆఫ్ వేవ్స్, ఓకే వేవ్ లెంత్ స్మాల్ ఉంటుంది కాబట్టి స్మాల్ రీజియన్లో కూడా చాలా నెంబర్ ఆఫ్ వేవ్స్ ఉంటాయి. that the number of waves present in a particular 1 unit length is called a wave number. So number of waves in 1 unit length means in terms of length lo combined calculate చేస్తుంది కాబట్టి the units are generally centimeter inverse. So very small region తీసుకుంటాం కాబట్టి that is generally used only centimeter inverse. So very rarely they take so other type of units. Okay, very rarely they took a meter inverse, but centimeters inverse the perfect unit. So meter ante very long. Okay, so this is a wave number. Like there is one more property. So one more important property of waves is amplitude. So amplitude generally indicated with A. So what is the amplitude means? Simply the height of crest, nothing but the depth of a trough. సో ఇక్కడ ఫర్ ఎగ్జాంపుల్ ఈ హైయెస్ట్ ఎంత ఉంది అనుకుందాం, ఒక ఎక్స్ సెంటీమీటర్స్ అనుకుందాం. సో ఆటోమేటిక్గా డెప్త్ ఇది ఆల్సో ఎక్స్ సెంటీమీటర్స్. బట్ ఇఫ్ యూ టేక్ ఏ పర్టికులర్ యాక్సిస్ ఇట్ ఇస్ టేకెన్ ద నెగిటివ్ వాల్యూస్ మైనస్ ఎక్స్, దిస్ ఇస్ టేకెన్ అయితే ప్లస్ ఎక్స్ సెంటీమీటర్స్. అంతేగాని ఒక దగ్గర వేవ్ హైయెస్ట్ పార్ట్ లోయెస్ట్ పార్ట్ ఫర్ నార్మల్ లైట్ ఇట్ ఈస్ నాట్ పాసిబుల్. సో హైయెస్ట్ ద హైట్ ఆఫ్ ద క్రెస్ట్ and the depth of the trough are exactly numerically they are same values. Numerically they are having same values, but the sign is different. మనకి క్రెస్ట్ కేమో పాజిటివ్ సింబల్ యూజ్ చేస్తాం, ట్రఫ్ కేమో నెగిటివ్ సింబల్ యూజ్ చేస్తాం. ఓకే, మీన్స్ సింపుల్ యాంప్లిట్యూడ్ మీన్స్ నథింగ్ బట్ the height of crest, or simple the depth. The depth of a trough is known as amplitude. Okay, next the one more important is there, that is about velocity. One more property. So velocity of light. So not only velocity of light, velocity of any wave. So velocity, there is no normal, we know the definition. So the distance traveled by any object in 1 unit time is called its velocity. In the same way, the distance traveled by a wave in 1 second of time is called its velocity. So generally their velocity is equal to already we know the velocity of light. So not only light, the other rays are also having all electromagnetic radiations. For example, X-rays, gamma rays, radio waves, cosmic rays, visible rays, ultraviolet rays, all are having same type of velocity. So this is the one and only property which is equal for all types of electromagnetic radiations. For example, just now we discussed the properties of frequency, wavelength, wave number. All these properties are different for one type of radiation to other type of radiations. ఇప్పుడు విజిబుల్ రీజియన్, ఈవెన్ విజిబుల్ రీజియన్లో కూడా మళ్ళీ విబ్జా 7 కలర్స్ ఉంటాయి. దట్ 7 కలర్స్, ఎక్స్రేస్, గామా రేస్, ఆల్ టైప్ ఆఫ్ ఈ రేడియేషన్స్ ఏంటంటే they are mainly differ in these properties. And what wavelength, frequency, wave number, total difference ఉంటాయి. Okay, they're not at all equal to each other, but the velocity of the light, nothing but all electromagnetic radiations are having same velocity. So what is that the value that is taken as c? Actually the c perfect word is used for the velocity of light. So the others, all types of electromagnetic radiations are also having same velocity, that is a 3 into 10 power 8 meters per second, and we know its value in centimeters, 3 into 10 to the power of 10 centimeters per second. So one more important, even in the vacuum, even in the vacuum is also the velocity of light is this only. Okay, and it is constant for all type of electromagnetic radiations. Okay, so these are the main properties. Now we see the relations. Of this between these properties. Okay, so first write the definitions. Okay, so not only understanding, you must be able to write the definitions also. Okay, so the mainly we are writing the main definitions. So first, what is electromagnetic? Why they are known as electromagnetic radiations? So why they called as electromagnetic radiations means, so normally electromagnetic radiations are formed so the radiations are formed as a result of oscillating electric field and magnetic field, which are perpendicular to each other, and they are also perpendicular to the direction of propagation of light. Direction of propagation. So just now we draw the diagram. So vertical electric field, horizontal magnetic field. You must draw that diagram here. Okay, it is compulsory. So that's why they're known as electromagnetic radiations. Means the light is nothing but known as electromagnetic radiation. So how the three manaki the propagation of the light, electric field, magnetic field, the three are perpendicular to each other. So how it isn't a, so it can be explained with the help of simple fingertips. That is, for example, see this finger. So this is the propagation of light and kunda. This is the propagation of the wave. So then vertical. So this one. So this vertically there is a electric field is there. Next for this. So this is a this is parallel one. Okay, ఈ propagation of light కి ఎట్లా ఉంది parallel గా they are present in the same plane. So ఈ డైరెక్షన్ లో ఉండే అంటే ఈ మోడల్ లో ఉండేది ఏంటంటే that is a horizontal one means magnetic field. So again this one perpendicular to each, even they are present in the same plane, they are perpendicular to each other. The path of the light ki electric field ki, so perpendicular and it's a vertical one. Next path of the light ki this finger direction means this is a horizontal one, but they are perpendicular, that is magnetic field. So again these three are perpendicular to each other. Now we see the properties of waves. So characteristics of waves. Wavelength, so there is simply lambda. Okay, so no need to write the separate point that it is denoted with lambda. Just remember it is a lambda. So wavelength means how we can define. So the distance between, okay, the distance between two continuous or two successives, between two successive troughs or crests. So what is wavelength means? It is nothing but the distance between the two successive troughs or two successive crests. So you have to take this diagram. So this is the distance between two successive crests, or the distance between two successive troughs is treated as a lambda. So what are the main important units? Okay, units are very important. So generally the units is, we know that angstroms, so very rarely centimeter, so picometer, nanometer. So generally we use in angstroms. One angstrom, this relation also very important. One angstrom equal to 10 power minus 8 centimeters. So 1 picometer, nothing but 10 to the power of pico means minus 12 meters. So again we know, again we convert it into centimeters. It is, these conversions are useful in the problems. Okay, 10 power minus 12 meters, 1 meter equal how many centimeter? 100. Again in 200 means it comes to 10 power minus 10 centimeters. Or 1 nanometer equal 10 to the power of minus 9 meters. 10 power minus 9 meters means converted centimeters. Centimeters, 1 meter equal to 100 centimeter. 100 means 10 square. That becomes 10 power minus 7 centimeters. So also convert into meters also. Okay. So only centimeters, meters, అన్నిట్లో value తెలిస్తే it will be better in the problems. So 1 centimeter means how many meters? 10 power minus 2 again. So there is a 10 power minus 10 meters. Okay, so these are the, this is about wavelength. Next, frequency, new bar, sorry, it's just new. Frequency means new. So how you define the frequency? So frequency is nothing but the number of times a wave passes through a given point. In a medium in 1 second. In 1 second of time. So the number of times a wave passes through a given point in a medium in 1 second of time. So or it may be defined as the number of waves. So మనకు ఒక రేడియేషన్ తీసుకుంటే అన్ని సేమ్ టైప్ ఆఫ్ వేవ్స్ ఉంటాయి కాబట్టి సో ఇట్ ఈస్ గివెన్ ఆల్సో లైక్ దిస్ అనమాట. వీ కెన్, వాట్ ఈస్ ద ఆల్టర్నేట్ డెఫినేషన్ ఈస్ ద నెంబర్ ఆఫ్ వేవ్స్ passed through a particular point in 1 second of time. So both are equal, that denoted with the new. So So what are the main units? The units in 1 second of time means the units are second inverse, heads, kilohertz, cycles per second. Here the relation is very simple relation. So there is nothing to mainly remember. There already we know that second inverse numerically equal to heads, which is also exactly equal to cycles per second. Okay, these three are having numerically same values. We no need to change in the problems units. But the kilohertz, we know that kilo means that 10 power 3 hertz. Okay, this is about frequency. Next one more property we see that is a wave number, that is treated with that is denoted with the nu bar. Okay, so it is defined as the number of waves. Number of waves per unit length is called wave number. So per unit length, so generally we write the units. If you take the centimeter inverse, or if you take the meters, it is the meter inverse. Okay. Next, the one more important property we know that amplitude. So amplitude, so it is denoted with the capital A. So amplitude means, just now we discussed the height. The height of a crest or the depth of a trough. So no need to write all this. So the height of a crest or the depth of a trough of a wave or in a wave is called amplitude. So the amplitude units are generally centimeters, okay, angstroms, like that only. Okay. Here main what is the importance of this amplitude is, it is generally used to measure the intensity of the radiation. Intensity. Intensity of a radiation is proportional to amplitude square. Okay, there is we have a relation, that is intensity of a light of radiation is directly proportional to the A square. Okay, so these are the main properties, and the one more property was there, so which is same for all types of radiations, that is velocity. So the distance traveled by the wave in 1 second, so is called velocity. Is generally denoted by expressed in c. Okay, so what are the units? Units means that is centimeter per second, meters per second. Okay, so what is value its value 3.8 into 10 to the power of 8 meters per second. 8 into 10 power 10 centimeters per second. What is the importance of this property is, so it is constant, means we can write it is same. So constant nothing but same for all types of electromagnetic radiation. For all types of electromagnetic radiations. Okay. This was about the main properties of the light. So tomorrow we, in the next class, we exactly see about the relation and the problems based on their relation. Okay.